All right, boys and girls, here we go. New unit, gases and gas behavior. So in other words, how gases behave under certain conditions and how to calculate their behavior under certain conditions. So here's our objectives. We got three big ones. One talks about the ideal gas law. The other one talks about the combined gas law. And another one talks about how to distinguish between pressures and how to calculate in between them. All right. So there's some words that are going to be useful here and which you're going to use for this unit and really specifically for gases. For example, pressure. Pressure is the physical force of molecules around something. All right. So the more force they have, the more pressure they have. The less force they have, the less pressure they have. So for example, pressure would be great when you're diving deep into the ocean because there's lots of molecules exerting a lot of pressure around you. That's why your ears hurt. All right. However, if you go in a plane, there is less pressure because the higher up in the atmosphere you go, the less molecules there are, therefore the less pressure, the less physical force they apply on you. All right. And the less pressure you have, therefore your ears want to pop. All right. So this is the physical force of the molecules around you. I love my handwriting. You can like it too. All right. Volume is just basically, an area. So basically, it's a physical, three-dimensional measurement that the area that something takes up. And area would probably be a bad word because area is only a two-dimensional. So it'd be the volume would be like the cubic centimeters, a three-dimensional area of a space that the gases will occupy. All right. So this is the space it occupies. All right. Temperature. Obviously, we know what temperature is. Temperature should be the average kinetic energy okay, yeah, I spelled it wrong, but short abbreviation. All right, it's the average kinetic energy of the molecules around you. All right, and when we're talking gas laws, we want to have all of our calculations in Kelvin. We don't want any negative numbers because it's going to throw it off. So realize when you have Celsius, convert it to Kelvin. When you have Fahrenheit, convert it to Kelvin. Everything should be in Kelvin for these calculations so that you don't get negative numbers. The two laws we're going to deal with the most are ideal gas law and combined gas law. The ideal gas law is under ideal situations, all right? In other words, like standard temperature and pressure. So it's basically a law. So a law that predicts the behavior under ideal conditions. All right, and those ideal conditions, you got to think STP. STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius, and standard pressure is 1 atm. So I believe it's 0 degrees Celsius and 1 atm off the top of my head. I'll double check that before we go over it in class, but I'm pretty sure it's right. All right, so this is under ideal conditions. In other words, under these certain conditions, all gases should behave the same or close to the same. All right, so it's an ideal. It's kind of like it's how things should be. The combined gas law deals with three factors, okay? And the three factors that it deals with are going to be pressure, volume, and temperature. And as one changes, you should be able to predict what's going to happen to the other one. So like, for example, if pressure changes, well, what happens to the volume? If temperature changes, what happens to the pressure? And so on and so forth. So it deals with three variables, and the reason why it's called a combined gas law because it's a combination between Boyle's law, Charles' law, and Gay-Lussac's. It's French. All right. So those three guys you put their laws together, and you get a combined gas law, which we're going to talk about here in a little bit. So here's your introductory. Make sure you check out the chapters and the pages to get a little further reading. And I hope this video helped. We'll talk to you guys soon.